Welcome to Network AF, a journey of super nerd proportions into the world of networking, cloud, and the internet. I'm Avi Freedman, networker, coder, husband, and CEO of network observability company Kentik. On this first episode, we'll talk with my friend Andree Toonk of OpenDNS, BGPMon, Cisco, and multiple networking projects about career and networking evolution. Some of the takeaways you'll hear are about overcoming intimidation, staying connected to mentors, driving your own growth. And on the networking side, we'll talk about the internetworking world, SRE and networking and the relationship, and some of the trends in desegregation and cloud scale networking. Welcome everyone to Network AF. I'd like to introduce my friend and fellow networker, Andree Toonk. Andree, if you could give us a brief background about yourself and what you've been up to and what you're up to now.
All right. Yeah, thanks for having me, Avi. So my name's Andree. I'm based out of Vancouver, Canada. Like everything networking and I guess what we now call DevOps. So I've been sort of doing that for the last 20 years. I think what's unique is that I've always had one leg in what I call DevOps now and sysadmin in the past maybe, and networking in the other. So really always try to take the learnings from mostly sort of the DevOps world into the network world. It's been a lot of fun. Started my career at the Amsterdam Internet Exchange, worked for a few ISPs, moved to Canada, Vancouver, 15 years ago. In 2012, joined a company that really changed a lot for me called OpenDNS as one of the early, what was back then called ops engineers. Mm-hmm. That was a lot of fun. And, you know, when I joined, OpenDNS had a few POPs or data centers. I recently left last fall and I think they're up to 40. And so that's been a very exciting and an interesting journey and learned a lot there. And then also, I think one other thing a lot of folks might know me from is I founded a company called BGPMon. And I know a lot of folks. Yeah, I know Kentik, obviously, and Avi through that and through Cisco. And I know at Cisco, we were big fans of Kentik. And so, everything around BGP monitoring, hijacks, outages, and that kind of cool stuff. And I know, Avi, you're super interested in that. And you even had a predecessor to that. I think it was called Watch My Net or something.
Yeah, it was Watch My Net. Andy Freed. Actually, I met Gadi Avron at a convention for people that run science fiction conventions. And he did the... taunting me to discover whether I was a worthy nerd, which I don't really enjoy. But anyway, I did that. And then he's like, you can't build a BGP monitoring system. And I'm like, well, I don't really do the front end, but I could certainly build
I remember the front end was like a Perl CGI.
It was PHP, yeah, with a friend of mine, Andy Freed. Now it's Spamhaus actually did. But it was like a week. I'm like, and I tried to compile my old BGP implementation that I wrote for my interview at AboveNet that used to run the RBL. And I was like, I guess BGP's changed a little. So I found some BGP Perl thing and made it work and, dumped the things and did the grepping. And I just didn't really try to I should have, but, BGPMon did well. And, maybe not. It did well. Got a huge community.
I got a huge community, and eventually got acquired, and is now still, I think, being run by Cisco. Although I think they're shutting it down. But you might actually know better by now. But
it got rewritten and put into something, and now they're a respected competitor because Kentik has just launched.
Kentik's doing something similar. So, I know. Obviously, you guys have Doug Midori, who's like an expert in this field too. So anyways, that was a really fun journey, and then I left Cisco. So a lot of that was around that last fall, and right now I'm on a bit of a sabbatical and trying to figure out what I'm going to do next.
Okay, well, we can talk about that because I am only one of many people I'm sure that has tried to recruit you, and you've been like, no, it's okay, but have been following some of the fun stuff that you've been doing, which again we can talk about. So what got you? You said systems. I know a lot of people are like, oh, networking is hardware. It's like, really? I mean, it's hardware that runs software. Systems are software, that can run networking. I mean, I've always seen that it can be a continuum. But like, what got you into the networking, especially internetworking, but networking overall side of things?
Yeah. Well, I guess I was lucky. When I was in university, we had a teacher that somehow, I guess, got a deal with Cisco, and he had these Cisco labs, and CCNA was just becoming a big thing. And I guess Cisco had sponsored a lab in my university. So they had all the gear, and then they had also just released all these kind of Flash-based tutorials, like exam material that you could basically follow, and then you learn about networking. Mm-hmm. Turned out that I had just moved out of my parents' place to like the university there, and I didn't have too many friends there yet. And the ones that I had, they still lived at home. So I kind of got used to that lab, and it was open basically till midnight. And I was like, this is all. I got addicted to it. It's a lot of fun. And then I just started doing them, and then I got really interested in it and got really good at it. So that's how it started. That's how I originally got into it. Although, to be honest, I guess I worked at a help desk before as well. But this is really how I got into the networking. Yeah. Then I got a gig at AMSX, the Amsterdam Internet Exchange, which is like, one of the larger internet exchanges in the world. That's where I even learned more. That's, for me, this is where the door opened beyond the default route. So I didn't know, like I knew BGP, right. And it's like you set a default route to your ISP, but it never occurred to me, like, what happens after the default route? And then I ended up there and was like, wow, there's a whole world behind here, which is super fascinating. And I really never really left that world. Like that's, it's so fascinating. That's how I really got into it. Cisco labs, help desks, and then the door to the, core of the internet, between quotes. I
remember the first time I visited AMSX, the University Park side. And I'm not used to smelling smoke in a data center, but like people are still, that was long enough.
Oh yeah, that's right. Yeah.
Smoking in the lobby right outside the data center. And I'm like, usually it's bad if you let the smoke out of the computer, the magic smoke, is what makes it run. And then I remember they had like, that was, I think the first time I saw like the forklift for like sticking stuff in. And of course the glimmer glass, which if it was in the United States, you would think was for the NSA, but was actually for an interesting approach to layer zero HA.
That's it's interesting you bring that up. So my first real job was at Sarah, which is in the science park where a lot of the AMSX stuff is. Some of my coworkers are still smoking when I worked there. And so I worked on a network called SurfNet, which is sort of the Internet 2 of the US. But one of my first automation experiences, like network automations, was all around TL1. And I worked a lot with someone at AMSX, and Arjen, if you're listening, and they were automating the glimmer glass with TL1. And we had a lot of optical gear, like Nortel gear. So telco gear has a standardized language, which is called TL1, for folks that don't know that. This is a really obscure thing.
I didn't know that.
Okay, yeah. So all the telco gear seems to have, or at least in the past, different vendors, Cisco, Nortel, Sienna, all spoke the same kind of language. And so we built some Perl libraries to automate that together with the
awesome
folks at
Perl
AMSX. Yeah. To do the glimmer glass. Yeah.
Actually, for those that don't know, it is an interesting take. I don't know if they still do it anymore, but the glimmer glass was sort of like it was an active. The idea was you'd have a standby port. It would be watching, so it'd be doing the MAC learning, and then when they wanted to maintain a switch, they'd flip over to another. It was like
I think they just had basically two switches. So what a glimmer glass is basically a big switch with mirrors in it. Right. And it's an optical switch, but it's a very dumb switch, right? So it's either goes to switch A. So the cable comes in and says, oh, I wanted to go to switch A. And then switch A is unhealthy. Well, then they change the mirror slightly and then it will go to switch B. Sure. And so the advantage as a customer was that you only needed one connection. And then sort of on the provider side, they would just say, oh, switch A is unhealthy. We'll switch you to switch B. Yeah. And then you want to automate that. But the cool thing is that it was all optical with mirrors, essentially.
Yeah, automated mirrors, pretty cool.
Yeah, automated patch panel, whatever you want to call it.
Yeah. So, did you have great mentors? Were there, how did you, get? Was it, you did the lab yourself? Did you have people pointing you at the things to learn, and was there that kind of culture there at the time?
I think sort of if I think back about the lab and really getting into networking and Cisco, and a lot of people give crap on like the certification programs, but to be honest, I think if it weren't for those, I would not have gotten into it. I think it gave me a solid kind of background in terms of like what is BGP, what's OSPF, what's whatever, and actually some hands-on and getting some of the basics in. And so for me, that was a great way to get in. I was surrounded by sort of that teacher and a few other folks that shared that passion. I don't think if there was really a mentor there at that point, it was pure passion, but certainly the opportunity was created for me to spend however much I wanted on like all the cool gear. if I think about mentors, I've had a few over my career, but I think early on, when I was still in the Netherlands, there was someone named Ronald at Sarah, and he really got me into the automation type thing. He was a really smart guy, and in university we had to do some programming. But I never enjoyed it. I never really got into it. And but I guess the problem was you were just doing puzzles. And I was like, right. I don't get it. It's kind of boring. And I want to go back to the lab, And then all of a sudden I was running this. This was at SurfNet. We were running this, that's a very advanced network and very large. And because all this new gear and for especially the Nortel stuff, the network management systems didn't exist yet for Nortel. So again, in the telco world, you basically buy the network management system from the vendor. But because it was also new, it didn't exist, or it was very expensive. And so he and I kind of started going like, okay, how would we do this ourselves? And it was a whole, back then Perl was a big thing. And he took me under his wing. And then there was another guy named Marco who helped me with a lot of PHP stuff. And all of a sudden, my passion for programming kind of came back because all of a sudden I had an itch to scratch. I had an actual problem, and it would solve me sometime in the middle of the night or whatever. When it took, I was a new engineer, sort of. So they gave me all the crappy jobs, like go collect all the serial numbers from all the devices. It's like, well, that's a 3-week job, right? Or I can spend 2 days programming this thing, and then run it in an hour, and it's done.
Laziness breeds elegance, in many people, right? It's why do I want to do this again and again and again? And it's an interesting theme. I guess we'll talk about it because some of the things that you've done are now living between networking and systems. But there were in some ways more advances in networking automation, at least the life cycle, even before that really became, crawled out of the high performance computing world and became cloud and SRE, and then I guess it sort of stopped for a while. But no, that's definitely interesting. So Avi,
just maybe one step back with the mentors, right? So there's been a few throughout my career, and those are the ones that really helped me going. And then I guess my message would be to folks that, do find mentors, people that want to help you. And, to be honest, it always sounds a little bit scary, but a lot of times it's just like find someone you respect or who is like, a few years ahead of you. And just, this can be a lot of things, but a lot of times it's just like unofficial, right? Just have a coffee with that person once a week or once a month. And that relationship changes over time and with whom, but there's so much you can learn from others if you're just kind of open to it. And even for me, even now I meet with a lot of folks, and sometimes they're just chats, and sometimes you're like, wow, they're full of gold. So I think it's very important. And I also tell people, like a lot of folks within a company have one-on-ones. So like, if I work for Cantic, I would have a one-on-one with you, for example, right, every week. But more and more, I find like it's very important to. So if you're doing that, keep doing that, but also do it with people outside of your company. So, that's a very well understood thing. But as you go further on in your career, there's only so much you can learn, and the company is a little bit of a bubble in itself. Mm-hmm. So work on like, hey, someone you worked with in the past, and that's a one-on-one too. Don't feel guilty that you spend an hour talking to someone at another company, because you're learning from that too.
Yeah, no, absolutely. Sometimes I get daunted when I looked at my LinkedIn, and I try to accept only people that I know, but you never really know what can come in the future, from staying connected to people, definitely for sure. The other thing I would encourage is, there's lots of different terms for the bright, shiny-eyed kid. But if you demonstrate that you are interested in learning and picking things up, there's often, especially in university, but even in companies, ways to get involved in, projects and learn. And, in a healthy company, in a healthy environment, people will invest in you, if it's clear that you're learning and growing, and hopefully we'll pay it back too, at some point. With COVID, we need to figure out some of these things, how that's all going to work and how we grow the community. But those are all things that we as a community are thinking about. So you mentioned sort of, I guess now we have to say SRE or DevOps or DevNetOps, but the link between these. And you certainly have come from the world of the labs, the actual Cisco 2500s and 7500s and such. and also, on the internet routing where it's already virtual, and OpenDNS was, services on top of, right, a network, with Anycast and load balancing and things like that. But I see you've been playing a lot with data plane networking, eBPF. Actually, the prehistory of Kentic was network sensors doing, packet stuff. And then I just got really interested. Customers said, what do we do with all the data? But, what was your interest in, playing with high-speed networking through systems and all the, the Linux, evolution around that you did stuff on?
I think there were a few things that drove me to sort of dig into it deeper. Some of it was driven by the things that were happening in my work environment back then, where at Cisco Umbrella, and a lot of other folks are doing this, is with what's called SASE, where basically what's happening is you're offering the typical network services as a service, right? So typical network components like a load balancer or a firewall or NATing or IPsec. And you see this in all the old cloud providers, right? Amazon has IPsec gateways or whatever, NAT gateways. But and so traditionally we would ship lots of appliances, so that doesn't really work anymore. And so the question then becomes, how do you build these things in a virtual environment in a cloud native way? And so that was something I worked on a lot and was super fascinated about, because again, it brought together sort of those two worlds that I was kind of interested in, and so that worked really well for me. And so there's two challenges to be solved. One of them is sort of the implementation on the control plane and management plane, because the nice thing about an appliance is it has ASICs and basically they scale vertically, right? They can do 100 gig in one device, for example. Well, there's no way you can get that out of a VM, right? So then you're faced with, you have to basically disaggregate that. And so now you need to have, let's call it 10 VMs to do the equivalent of one big box. And now you're basically into the distributed computing problem, and how do you synchronize state and all that kind of stuff. So that's a whole interesting problem. So that was part of the problem space, which is super interesting. And some people call it microservices, but basically it's a distributed computing problem. And then the other part is speed. These big boxes have ASICs, and they go like crazy. They're really fast, right? And if you do this in virtual environments, you actually have a problem because, there's a few problems. The first one you often hear about was Linux networking is slow, right? And that's kind of true, I guess, right? And so part of my journey was to define what is slow, what is slow. And so the conclusion was, in Linux, I'm gonna skip a whole bunch of details, but sort of you can do 1 million packets per second per core. That's sort of the rough
through the kernel. So just to be clear, through the kernel, forwarding using the IP stack.
Yes. Yeah. Thanks for clarifying.
That's the baseline, right?
The base thing. Yeah. And there's a whole bunch of details there, but that's a rough, if you want to take a number. If you just use kernel networking, you say the kernel does the forwarding. It's 1 million packets per second per core. So that's, whether that's slow or not, really depends on your situation. But certainly if you're trying to do 100 gig through a firewall service in a data center and you want to do that through that, well, that's okay. Now you really have to do, first of all, again, I'm talking about 100 gigs, but really what the number is we should be talking about is the number of packets per second.
Right.
And the reason why we say packets per second, because roughly speaking, again, I'm skipping a bunch of details, is every packet per second is an interrupt or a soft interrupt, essentially, right? And this is where the CPU speed then kicks in. So anyway, so that's, and actually we'll go a little bit deeper since we're here with Avi and we can go geeky. So that's just the kernel, right? But a lot of, and let's say you're a fancy shop and we're doing Kubernetes. Okay, cool. So what does a typical Kubernetes world look like? Well, actually you run Kubernetes with basically Docker containers on a VM host on hardware, right? And so typically in the world of Linux, you have these, what we call VEEF, virtual network interfaces, connecting them. So if you now look at the path and the cost that it takes to take a packet off the physical wire into, say, the hypervisor, so that's the first NIC you got into, the network interface. So that's an interrupt. So then you go into the sort of the VM host, and then you go into the Docker. And so there's typically 3 physical VEEF to the VM host,
plus
VEEF
the
to the
CNI.
container.
You might have
yeah.
a magic tunneling, policy enforcement.
Oh yeah, there's that too. So, but yeah, just as an example, so there's a few of these like virtual interfaces, but they all have a cost. They all have that 1 million packets per second per core type thing. So now if you have a simple scenario, as I just explained, and there's lots of variants, then all of a sudden your budget's cut in three, right? Very crude. Right. So anyways, that was something that when I was in that world, it's like, well, this sucks because how are we ever going to build a 100 gig IPsec gateway, for example, at a reasonable cost? And so so the long story short, then I started exploring what are the other alternatives. And so there's two main alternatives that have a bit of traction. One of them people have probably heard of is DPDK. And so DPDK is basically a very fast driver that bypasses the kernel. But it only
works well with spin locking, right? So
yeah, so basically the CPU runs all the time, whether you have packets or not. So it's a little bit of cheating, but if you work in network heavy environments, you probably don't care about giving up a CPU just for the networking. So basically it takes away, and this is part of the challenge, Linux is a multi-user, multifunction system. And so it's optimized to be as generic as possible. Right. Whereas for a lot of these workloads, actually, you don't want time sharing. You basically say, hey, this CPU, all you're doing is doing network packets. So then you could leverage the L1 caching and all that kind of stuff. So basically that's what DPDK does. But then DPDK only does sending and receiving. It doesn't do forwarding, for example. So now you need to build a network function that actually understands, well, this packet with this destination IP or MAC should go there.
Right.
That's what VPP does. So that we can dig deeper there. But DPDK and VPP is one option. And then you have, in the BPF world, you have XDP. So DPDK and VPP completely bypass the kernel, which is very interesting. So the NIC, the network interface, literally disappears from, if you do ifconfig or IP link, you don't see it anymore. You gave it to a userland program and that's taking care of it.
Can you use SRIOV and make some of the NIC interrupts disappear, or it takes over the whole NIC only?
Yeah, you can. You can do SRIOV, and then it makes it a little bit easier because then you don't have to have dedicated NICs.
But to simplify, right? Yeah.
Yeah. Certainly good for testing. Like if you don't have a machine with multiple, because then you need an out of band for management. So the other one is XDP, which actually is a little bit of a hybrid between the two, and it allows you to execute network code. So XDP is basically part of BPF. So a lot of folks have heard of BPF, and the specific BPF code related to networking is called XDP, Express Data Path. And it basically executes some of the network code a lot earlier on in the Linux kernel stack. And so as a result, it's a lot cheaper.
So before it's above the driver, but before the IP stack.
Yeah, it's after the driver, and it's like almost immediately after the driver code. And what they say in Linux, you have this concept of SKBs, which is a structure for sockets. And as soon as you get there, you get very slow. And so they said, we want to do a lot of work before that. And so that's what you can do. And so in one of my blogs, I said, okay, let's say you have two network interfaces and I want to route between them. I still want to use BERT or whatever as a BGP daemon and build then the forwarding in XDP, which basically it's really nice because you get to use still the Linux forwarding table, like the kernel routing table. So you can say IP route this IP address list behind that NIC, which again, if you use DPK and VPP, you can't. Like everything has to be done in userland.
You get zero kernel from DPK, but you get some kernel. Okay, got
it. And this was the big lesson for me, right? Like as we went into this journey, I was like, okay, what does this really mean? And it became very obvious. Yeah, if you take it away from the kernel and you have to do everything in userland, you have to re-implement everything. So there's no TCP dump, there's no IP tables, you can't type in IP route this. In fact, there's no TCP stack, right? So all of that has to be re-implemented.
It's like the monokernel. It's like people trying to make a monokernel to run a microservice, but for networking.
Yeah.
Yeah.
So you can do it really fast, but you better have to go all in a team to actually do that. It's not something you can just kind of do in the site.
So what was the answer? 1 million packets a second through the core through the.
Oh yeah.
What was the answer with XDP?
I don't have. I think with XDP it was something like 10 million packets per second, and with the VPP I think it was around 14 million packets per second per core.
Mm-hmm.
So, significantly more expensive or, significantly cheaper in terms of budget. So just switching to XDP, which is sort of a nice middle ground where you get some kernel functionality, but a lot of speed improvements. You got a 10x improvement or so. If you guys are interested, look at toonk.io. That's where all the details are. I don't recall the exact, but it was pretty impressive. It's a very steep learning curve though. Mm-hmm. And so you have to figure out if that's what you need. But certainly some of the new CNIs in the world of Kubernetes are leveraging a lot of that stuff. And a lot of the work, VPP and XDP have CNI implementations. So cool. That's a very interesting topic.
You've come a long way from not liking coding, but again, you have to find the right problem to solve to
yes.
So,
yeah.
No, that's pretty cool. I remember when I first started seeing people try to do this, and I was looking at SnapSwitch, and I'm like, that's pretty fast for Lua. Like, what's going on there? That's pretty interesting.
Snap is another one. There's a few out there, but I think XDP is gaining a lot of momentum, and I think VPP is super interested in as well. By the way, if you guys are interested in VPP, the project it also goes by Fido, and the project name is fd.io. It's actually a Cisco technology that they open source. Apparently, some of the Cisco products use it like internally, but it's pretty powerful. But I guess that's it. If you need raw power, go look at it. But you really need it because it comes at a pretty high cost in terms of like investing and understanding what you're doing.
Right.
It's not like I'm going to replace Apache with Nginx or something, right? And it will take 10 minutes to figure out. No, this is going to be measured in days or weeks.
Well, that's a separate topic maybe for another time. But the whole idea of white box and what's the idea of running Linux, and it's nice, but be careful what you wish for, when you don't have vendor support for everything. And I think, again, a separate topic, but I think there's been some interesting middle ground. But I want to ask you, so I saw all that work, which I consider to be low level. You have to know how the systems work. You have to understand what's in the kernel, what layer. I like that stuff. But then I've been looking at my socket. I'm like, looks like sassy, and I was following Tailscale and some of that stuff.
Yeah.
I'm like, so that's like, sort of up a level. And I was like, well, that seems pretty simple, but it seems like there's some interesting things that you can do with it. So I'm sort of curious what motivates you.
Yeah.
For myself.
You're kind of curious, like, what's this guy up to? He's all over the place. Then he's doing this, then he's doing that. So maybe, So first, that was all around the cloud native networking type stuff, the data plane networking and then the control plane. And then another project I was working on, is my socket. So maybe a little bit like what that is. So sort of the 10,000 foot level thing is, what is my socket? It's kind of an alternative to remote access VPN type stuff. So I think what is the challenge with the typical VPN is like when I was at Cisco, any big or like I want to onboard Avi as a contractor, and he needs access to wiki.corp.com. So I had to remember to create an IT ticket 2 weeks ahead of time, and then we create a corporate account. I would send you the AnyConnect client, and then you could VPN in. And then the challenge with that is, Avi is now VPNing in. Now he basically becomes a member of the network. Again, I'll use Cisco as an example. That's a very big network. So Avi's a smart guy. He's going to poke around, right? Yeah, see what he can do. And, it turns out we also gave him corporate credentials because we use SSO for VPN. And so now if he finds a GitHub server, chances are he can actually log in, right? So that's a typical problem. And so I was like, okay, how do we solve this? Now, there's a lot of people that have thought about this. And essentially what my socket was, it's like, how would you build a solution to that? Something like what Google calls Beyond Corp, other people have called private access, zero trust type stuff. So that's what my socket is. So the idea is that, you have this wiki server. It actually kind of dials out to, in this case, the my socket edge, a secure tunnel for just, say, port 443, that particular service. And then Avi says, okay, I want to go there, wiki.corp.com. And then we act sort of as this bouncer in the middle and say, okay, we have this checklist. Is Avi allowed? We also check what Avi's doing exactly. And then, and then we stitch those two connections together. And the nice thing is that the wiki example, it can be in a private VPC behind NAT because it's an outbound connection. So no VPN changes are needed. And Avi can be anywhere. And it can also be clientless. You don't need a VPN client or something like that. And so one of the things I'm doing, which sort of from a technical perspective really drives me, is like, okay, HTTP was relatively easy because there's a lot of proxies out there.
Uh-huh.
So how do you build more application-aware proxies? And with application-aware proxy, I mean like it can speak the protocol like HTTP.
Is tough? Is Quick tough to?
I haven't looked at Quick. The ones that I've been looking at are more the typical remote access use cases like SSH. Okay. So, have a Bastion host. Normally you need a VPN, right? Or a router. Like I don't want to use the VPN. Okay, well, how do you do that? So then I built my own sort of SSH proxy, your own implementation of that. And with things like Go, it's actually relatively easy. So I learned a lot of Go. And because you speak the protocol, we can do session recording, we can kill sessions, all that kind of stuff. Building an SQL proxy right now where we can log all the queries, or can even modify what's getting back. So if Avi does a select on users, I'm garbling the email addresses or something. Mm-hmm. So that's the kind of stuff I'm working on with my socket, where you're basically sitting in the middle as this application-aware proxy and provide policy, authorization, authentication, and enforcement and recording and stuff like that.
Yeah, I would encourage people that are looking at trying to play with technology to look at what Andree's done. I like I try to think the same way. What's the minimum covering set that I can build to demonstrate the concept, and then build on top of it towards, and then all of a sudden it's like, oh, look, it's a SASE zero trust and everything platform that you could do, whatever with. Then that'll be the interesting question to ask next time: is what are you going to do with it? Just project or company side, because there's lots of different takes on the direction things are going. I'm actually in Vegas. This is my virtual background, but of my actual home. But I'm in Vegas at Black Hat. As we're trying to. It's much smaller than before, but it's just interesting to try to poke through the marketing and figure out what people are actually doing.
And that was part of my journey as well. Like a lot of these things, I start with I don't really understand what this. I keep hearing about it, and then I get slightly frustrated because I don't understand it, right? So that's how. Let's just build this DPDK thing or HTTP thing, and in this case, zero trust is very popular, and I was like, I don't really understand anymore what this is, and I just go ahead and go well. If I would build it, what would it do? And then it's kind of a forcing function to go and figure this out. So I'm sure now that you're at Black Hat or DEF CON in Vegas, you've heard zero trust like a million times, and everybody means something different. It's been it's just a great exercise to figure out what you think it is, because you're forced to, if you implement it, you better understand what you're doing.
Yeah, actually in 2003, for the first issue of ACMQ, Eric Allman, who I was like, oh, Mr. Sendmail, reached out and was like, would you do an article for this? And I'm like, what do you want to write about? And I was like, I don't know what to write about. He said, what does Port 80 make you think of? You're at Akamai, I'm like, it makes me think, I think I can say this, of the illicit tunnels that I have through Port 80 to my home stuff because they're firewalls. I didn't like the firewalls. And I'm like, so I wrote it, it said securing the edge. So if I had said zero trust, it would have been really cool. But
yeah, you were way ahead of your time then.
But actually, I just was talking about IP. So I didn't have the user concept, in there. But, obviously. Yeah. Nowadays, that makes sense, right? Who's the user or the role or the service or,
tie it all together, right? User, expected role, and then the application. And you can tie in contacts like, hey, Avi is all of a sudden in Vegas at Black Hat. Yeah, maybe we want to. Yeah. And his laptop's doing all kinds of weird things. So maybe we want to drive back a little bit of his permissions and stuff.
So you mentioned something which I think is pretty cool because, it's been part of the journey of networking for me is, I describe networking sometimes as lots of little simple things that interact in complex ways convolved with vendor bugs. And, the average sysadmin might find a kernel bug in their lifetime nowadays. It didn't used to be the case, but nowadays. But the average network practitioner, it might be monthly or quarterly or yearly, depending on, how active you are. And sometimes, the other thing with networking that I've found is that, it can be hard until you put your hands on. You think there's complexity that there isn't. Like I remember when I was learning BGP, I'm like, there must be performance-based stuff. Something must make things change when the performance is bad. And like, no, there isn't. And so, what you just said is really powerful, which is like sometimes you just need to put your hands on, whether it's because it's all marketing or because, it can be hard in any kind of technology. To see the description and put it in your head until you really put your hands on. I love that you're making, all the blogs available and all that, but, and code available for people to play with too. That's pretty cool.
Yeah, no better way to demystify some of this stuff than just getting started. But to be frank, it is scary, it's intimidating, and it takes a lot of time. So you do have to have that time. Not everybody has that, and especially not every employer allows you to do some of that stuff. But that's the best way. Just keep your hands dirty, and stay in shape, essentially.
Yeah. So one of the things I like to ask people is sort of what's hot and what's hype. So it sounds like you're big on, you're both big and hypey on SASE, but you're big on the what you can do with Linux and disaggregating. But I guess I'll ask you, the question, like, what do you think in networking in general is like, really, really cool? And what do you think is being talked about maybe more than it should be?
Ooh, that's a deep question. Yeah, there's a lot of hype around, zero trust and stuff like that. There's a segment of things called SDP, software defined perimeter, which is actually quite interesting. So I don't know if this is exactly your question, but certainly what I've seen over time, and a lot of actually folks like you will like. So traditionally, networks are dumb. Like this is a quick, dumb, fast pipes. And then there's been this trend over the last 20 years, somewhat driven by people like us that want to make more money out of the network, or our employers want, is like to put more smarts and services in the network gear, in the firewalls, and like all that kind of stuff. And in fact, Kentik is a company like we want to extract value from the network, value in terms of visibility and stuff like that. And unfortunately, as an industry, we have been trying to put more and more stuff like that into the devices, into the networking. And so network gear has gone from just doing layer 2, layer 3, all the way up to layer 7. And this has been very, I've seen this around me, I guess stressful or difficult on network engineers. And, that's why I, heavily biased, think in terms of engineers, internet engineers, network engineers are some of the best around, because they are forced to understand the full stack. If I remember outages in various companies, that if there was an outage, it was typically the network engineering team that, first of all, they had so many scars, they were battle hardened, so they were cool under pressure. Right. But they also understood in a lot of chaos. They were very good in like trying to figure out where is the problem. Is it in this stack, where? Because they understand all that. Mm-hmm. But there's also a lot of cognitive overload. So this has been great, or it has worked well for people like me and you that have been, every year we learn something new, and sort of we've been driving or sort of serving that wave. It's a lot more challenging for people that come out of university and want to become a network engineer. Right. But first off, I don't think there is an education or a program. There's lots of computer science stuff, but so that's a problem. And I don't know if that really ever existed. But the world into sort of network engineering was a lot easier. So there's this problem for new engineers and even existing ones that I call, just cognitive overload. You need to do so much nowadays. And depending on where you work, the network's either seen as a valuable asset. Certainly the world that I came from is like we were delivering network add-on services. So it was seen as a strategic advantage and same for Amazon. The more we invest in it, the better, and it's necessary. Whereas if you work in a more enterprisey environment, you're typically just a cost center, right? And so that's very challenging. But you still have to deal with this cognitive overload. So why I'm saying this is like I feel like we've reached a top, like a peak. And right now, what you're seeing more and more is that networks are made dumber again, which is a good thing in my opinion. And we talked a little bit about service mesh, and a lot of that stuff is now built into applications essentially. And I think service mesh, as hypey as it may be, and like that's a whole question. What does service mesh mean to you and me? But a lot of times, I think that's interesting that you see. So basically, what service mesh provides, it's an alternative to your traditional load balancer or traditional firewall or whatever, right? Where traditionally we would put a load balancer in the network, and we would funnel all the traffic through there, and from there on, it would go to the things again. Service mesh is different; it solves it in a much more meshed way, if you will. But it's interesting that those responsibilities are now being basically put in a different part of the stack and also in different teams. Similarly with security, where you had firewalls. But if you look at the cloud, we don't have firewalls anymore. Now we have security groups and whatever, and they're managed by the teams itself. And I think those are all good things because no network engineer I know ever liked doing ACLs and stuff like that. Although they were always the voice of reason, like, are you sure you want to open this up to the whole world?
Right.
So I think that's a bit of a trend that I'm seeing where, and I think that's good for network engineers. It's also good for innovation in general because other teams can kind of reimagine that. Now, whether that's going to be as scalable and as good, like look at Kubernetes networking. It's like it's getting better slowly, but it's been a big mash.
Kubernetes networking is flexible.
It's flexible, but if you came from the world where I came from, where you want to build network functions, like you want to build a firewall, okay, so first of all, I have to go through these 3 levels of network interfaces. Oh, and by the way, there's like 3 levels of NATing as well. It's like, this is great for proof of concept lab stuff, but there's no way I'm going to get significant amounts of traffic through this, right? So I mean, that's part of just the evolution. Eventually they'll solve that. But I think certainly a trend that I'm seeing. And I'm not quite sure if it's good or bad, but it's certainly good for network engineers that have this tremendous cognitive overload, I think.
I think it's, when I was an ISP in the 90s, every year, it was like a paradigm shift. And it was awesome, for people that hate being bored, which I hate being bored from a technology perspective. But I do see a lot of customers, a lot of people sort of confused between the service mesh and then Istio was going to be hot, but it's a coordinator. So what are you running underneath? And then network mesh and what some of the network meshes are doing. Because ultimately there's policy, there's load balancing, there's telemetry, there's all these things. And I do sort of like the separating into dumb pipes versus the services on top. But I think there still is a lot of question about, is it going to be, how much is sort of the load balancing service meshy stuff, and how much of that network intelligence and balancing and things like that are going to happen down there. But it's interesting to see. I agree. It is an area of hotness and hype, altogether. We see a lot of innovation, and I look forward to seeing and figuring it out. We keep it pretty simple with our infrastructure back end, because we want the training to be simple and, stuff like that.
It's super fascinating. The network service mesh stuff, like, basically all these overlay tunnels going everywhere. It certainly allows for more innovation, I find. Like, I know we got a lot of questions from that, sort of from other teams to the network teams that I led. And we wanted to do it, but there just wasn't enough time. And then what you see in several companies is where there's now 2 teams. So now there's the network team, the big pipe, dumb pipe stuff. Right. And then there's an overlay team, for example, somehow embedded or, however you want to implement that. And that's where you get to do a lot of smart. So, okay, I only can see the networks that Avi has invited me to. And, we provide the encryption on that level versus sort of the underlay level. And we provide authentication on top of that and failovers. And now it's all software. And so you're no longer limited in what you could do on the big Cisco, Juniper, Nokia, whatever boxes, right? And now what you want to do is only limited by your imagination. And so that makes me very excited.
It's good. Yeah. It's exciting, but it's scary because how do you document like all these? Again, it's many simple things, but they convolve in complex ways. Something else you said, you're talking about the lab days when we started talking. And it used to be said that, until you've destroyed a system, you weren't a real sysadmin. Until you've taken down the internet, you're not a real, internet worker. Is that easier or harder? I mean, do we have labs that simulate that? Was there more freedom, less freedom?
That's a great question. Yeah. I have a few of those scars myself. I'm very proud of them. I wear them with pride, but if I think back of them, they were very stressful. And I can, having worked in a lot of operational environments and seeing, training new engineers, sometimes I feel a little bit bad because it's a lot harder. Well, it's still very easy to make those mistakes, unfortunately, right? So although we try to put in more controls, but the cost of making those mistakes are so much higher nowadays, right? Where when you created some kind of routing loop, or I dropped an ACL somewhere and, a pop went off, that sucked for a few minutes, but then it wasn't the end of the world. But now, depending on your environment, there's like millions of dollars and just really bad press or whatever. And so I think those mistakes will still get made, but the cost is a lot higher. And it will make a lot more impact on the engineers. So I think that's so you see this trend now with hookups, when there is, and I think that's great. That's been a change over the last maybe 2 or 3 years, because, outages do happen and humans do make mistakes. So hopefully we'll learn from it. But it's certainly, I think, and harder. Well, it's not harder to make the mistakes. Maybe it is, but the cost is so much higher. So people are less willing to experiment. They're a lot more careful.
Yeah, no, it's definitely interesting. People are trying to do labs like to simulate the internet and peering and all that, especially because it's not just about technology, it's about politics, which is sort of layer, depending on how you look at it, especially with internet, engineering. But, how do you, help there and give people, because sometimes until you really get it in your head, like the dangers of redistributing routing, which hopefully no one's doing much, but routing protocols, but like until you see it and it can be hard to really internalize. And the thing about automation is it can save a lot of time, or it can do the wrong thing really fast and really well, because computers are dumb and will do what you tell them to do.
Yeah.
So
you want me to remove this thing? I've done it everywhere now.
Yes.
And there's a global outage. And, every now and then we hear, recently there was, something with Fastly and then Akamai, I think 2-3 weeks ago, and it's just hard down, right? And, whether that's network related or DNS, it's the same type of challenge. I fully agree. And the other challenge is, as we are trying to scale these environments, we're actually putting layers on top of that. So there's a lot of network engineers, between quote, and I don't mean this in a bad way, that actually never log into routers. All they do is make changes through a GUI or a pull request in a Jinja template, and then magic happens, which is great for scaling and automation and makes the network safer, assuming you do testing on them. But the challenge then becomes, okay, now it broke. And eventually something's going to break, whether it's a bug or whatever, right? And now all of a sudden you do have to log in. And then, one of my worries is that over time we lose that knowledge, that someone that can log in and understands the TCP three-way handshake to BGP handshakes, and why is this route flapping or stuff like that. And that's a very interesting challenge as we scale up. Like, how do you keep that sort of more and more niche knowledge? How there are enough people that keep doing that?
Yeah, I as an observability vendor, I like to think at some point we'd have all the telemetry and whatever to do that. But as you said, sometimes you need to get the TCP dump because there's something in the middle which you're never going to get telemetry from, which is behaving poorly, and you need to be able to point the finger and go figure it out. It's sometimes it has been handy. Sometimes my fingers actually know more than my brain what to do on a device. As you mentioned, you do need to get baked a little bit under pressure sometimes. And sometimes it's helpful to have your own parallel processing of like, there's the incident, here's what I'm looking at, and here's what I'm there. So it's something I'm thinking about. And I think the community's thinking about is, especially with COVID, because networking, especially internet networking, has always been a little bit of a tribal knowledge and an apprenticeship. And, in the 90s, yes, you didn't graduate to above journeyman until you actually broke something and changed it so that
congratulations, here's your medal. Now you have, root access.
Exactly. But it's hard to really understand how bad the internet was in the 90s and yet it all worked. Now that we live connected over it. So those are things, look, we're all going to think about, blog about it if you have any great ideas, and something I'm going to keep asking people about. On that note, any advice you'd give younger Andree, through the career?
Younger Andree, I don't know. I think I was very lucky to just stumble into the right things and be surrounded by, this lab and the right people early on that you just kind of, I guess, directed me in the right way, and was lucky to take the right risks and just have a good environment and good people around me. If I think about new network or people that are interested in this, or maybe you're just getting started or earlier in your career, I think find those people that you think you can learn from and that are willing to spend some time with you. Find an environment in a company where things like experimentation are encouraged versus like, just don't touch it. It's just fear and you'll never learn much. And those companies do exist. Just talk to a lot of folks. Read things like Nanog and stuff like that. Even that has changed a lot. But even by lurking and watching the presentations, you'll learn so much. And to be honest, the one thing that was very important to me was that I early on learned how to code, essentially. And I still think that some of the best people I've worked with both understood basic, and I'm not like, you don't have to be diehard programming, basic scripting. And nowadays, especially if you're in networking, right, Python is kind of the go-to language. There's tons of libraries out there for network folks. I think that's very important. It will set you apart from some of the others. It will make your job a lot more fun too. I think there's just so much more. All of a sudden, you're no longer, handcuffed by what the vendor allows you to do. You can build your own systems and change things. So I think that one is definitely one of my big tips. Spend some, and it's if you don't know how to do it or if you've never done it, it can be very intimidating. But this has been the same for me with like DPDK or XDP or Service Mesh. Right. I didn't know any of that. And so what's hard is to get started. And it's almost like, I don't know, this weekend, or I'm going to take 2 days off, or maybe if you're lucky, you can talk to your manager or your boss and say, hey, I want to spend 2-3 days just to get going, because those first 2-3 days are the hardest. And just watch some videos, do a course on, there's lots of course websites out there. And then once you get going, once you've written your first few scripts, then all of a sudden it starts to unlock, and then you can start to solve your own little problems. And then the future is limitless, essentially.
Yeah. So I guess I'll follow that up with a few thoughts. First, I want to encourage everyone listening to do what Andree's done. It's something I have done too. It's like, as you learn, document and teach. If you have a question that was confusing for you, guarantee you it's confusing to someone else. No, you will not look stupid. You will look smart by breaking down the things that were confusing and then how you got unconfused, right? It's like the kernel is this big thing, and then we try to understand what it is and hear in a different way, because different people learn differently, and need that. And so would just encourage people that also is really helpful to the community. And also acknowledge, which you've said a couple times, Andree, we've both been pretty fortunate and lucky that the things we found our way in, we had access, we had privilege to, take time and do what we thought was interesting. If people are looking to get in, people are looking for mentors, people are looking for pointers, feel free to ping me. I'm Avi at avi.net, avi@kentic.com. People like Andree, if you demonstrate that you're reading and thinking and interested and can be passionate, we're happy to help connect you to people, in your area of interest, and try to grow the community, because it's something we're all actively thinking about as things get more and more abstract, and even as the world is opening up, hopefully safely post-COVID, there's going to be different patterns, and we need to figure out how to teach and grow these communities. So thank you for being on and sharing, Andree. How can people find you and reach you?
I'm on Twitter at Toonk, ATOONK. That's the best way to reach me. Or check out my website at toonk.io about all my adventures around exploring some of these things and learning sort of in the public.
Cool. Well, thank you very much. And I look forward to maybe in another year seeing what progress you've made on MySocket, and whether you have a third project, maybe proto company coming down the pike. So
awesome.
Thanks very much.
Well, thanks for having me, man.